Hi, my name's Courtney. I work at the Giraffe Conservation Foundation, and I'm here today talking about a few of our data integrations, as well as how we are applying the data we have collected to giraffe conservation. So a real sharing experience, I hope. I'm going to tell you what things I've been up to, and maybe you can tell me if you've got some better ideas, or it can help you with your ideas. We'll all share along the way. So there's a general perception that giraffe are everywhere, but they're not. That's not the end of my talk. There's been an 89% decline in their historical range. So that light, the mid-gray region on that figure shows the historical range, and the black area is their range now. So really restricted and a lot very fragmented. And because of this misconception, giraffe have been undergoing a silent extinction. And as with all species, and everyone will know this from their personal experiences, it's not a singular problem. There's habitat transformation, there's habitat loss, there's linear infrastructure, it cuts places apart, there's also mortalities on train lines, electric wires. And because of this, essentially, we're sitting with around 117,000 giraffe in Africa today. And depending on which species or subspecies you look at, some of those are really tiny and really fragmented, like those northern ones at the top in Niger and Chad, for example, compared to the southern species. But I'm not being a gloomy Glen. There has been a 20% increase in giraffe numbers since 2015, and at GCF we're working hard to keep that number increasing. Why do we care that we want giraffe numbers to increase? They are a keystone species. They have a big impact on the vegetation of the landscape, which trickles down to impact other species as well. But also, they make really fascinating study species for lots of reasons. They occur in a diverse range of habitats. So they're not everywhere, but they do occur in lots of different places. So from dense bush to arid open savannas. They're also really wide-ranging. They move far distances. This here shows the GPS data points from one male over the course of 1 year. This is in northwest Namibia. The purple line at the top, that's the border with Angola, to give a bit of perspective. But in a year, he moved over 3,500 kilometers, and his home range is over 2,500 square kilometers. Obviously, I'm using a really extreme example here, and resource dispersion has impacts on all of this. But what I'm trying to get at is, because they move so much, they have the opportunity to interact with many threats in the environment as they're going around. They're also really weird. Look at them. And that provides us an opportunity to be innovative. We didn't always have all these tracking technology solutions that we have today. So back in the day, when it was just really the neck collar that was around, we tried it and it didn't really work. I will talk more about that a little bit later. So for example, this one on the left was an adapted neck collar from the 90s that sat sort of on the shoulders. The wires twisted around, it fell off, didn't really work. We tried these little rugby scrum caps. They also were tricky because the ossicones are different shapes and the skulls are different sizes. We moved towards adding them to the ossicones, which are the horny deposits on the top of the skull. And there's some more developments, but I'll tell you a little bit more about those later. And because of their individual markings, we can identify to the individual. So we can monitor long-term population information, mortality, lifespan, herd associations, and that allows us to do some really cool analyses as well. I won't go too much into that, but we can have resites of the same individuals over time, which is really great. So at GCF, we're a small team. I think we're about 20 now, but we work across 19 countries in Africa. So we have a lot of a very large footprint data-wise. Some of these projects that we support, it's just equipment-based. Some we support surveys, some we do translocations. There's all sorts of different activities going on in different countries, meaning it can be really messy data-wise when it all comes into one place. Some of these activities include specific research questions, so putting GPS tags on, like what I mentioned before. Education programs, taking kiddies out into the fields, teaching them environmental awareness. Capacity building, GCF runs a training course for recently graduated vets from across Africa that does chemical immobilization for all species. And of course, translocations for reintroductions and population reinforcements. And all of this together is a lot of information that we want to try and streamline to make everything easier, because that's like the point, right? Want to make everything more streamlined, faster, get the information in, get what we need out so we can spend more time doing the important activities. Because essentially, we want to see more giraffes in more space, have more awareness and better capacity for achieving the GCF vision of having giraffe populations thriving across Africa. So here is a bit of an overview of our data workflows. And I'm going to go through them step by step based on the activities. I've got the activities on the left in orange, the data we get from those activities in green, the processing that's involved in purple, the storage and visualization platforms, which are in blue, the analysis, which is that gray one there, and the outputs, which are also orange. And I've made that because those outputs sort of circle back around into the activities. So it's not flat like this. Imagine it like a cone, and it goes all the way around and it keeps feeding back around. So starting with one of the activities that we do, which is photographic surveys. So we go around, do the same tracks repeated, take pictures of the individuals, and then we run them through AI and use a platform called Giraffe Spotter, which identifies the individuals for us. We don't have to manually skip through all the ID books anymore, like back in the day. And then we have analytical workflows in Python and in R that are hosted on GitHub that do our reports and publications that we need out of that. A similar workflow for our camera trap images as well. Giraffe Spotter, it's Wildbook, essentially. We just call it Giraffe Spotter. And this is a web platform that lots of different people can use. So anyone can submit their sightings. And if it's been recorded before, then it matches to the profile. If a giraffe goes across to a different site, if a giraffe goes to a different country, that person on that side can see it where it was sighted before. So it's a really nice collaborative tool. Moving on to our GPS tags. We currently use 3 different types of GPS tags. Savanna tracking iridium units that sit on the tail, and GSAT solar ear tags, but also Ceres ear tags. So as with lots of people in different parks, it can be really tricky when you've got all these different source providers. You want it all to come into one beautiful, perfect database, looking all clean, which happens to be EarthRanger. Our Savanna tracking and GSAT data feed directly into EarthRanger. So these dashed lines are automated processes. Go straight in, no worries. But Ceres do not integrate into EarthRanger. But I don't want to spend time sending it all in all the time and having those lags in the live feeds. So in partnership with African Parks, we've developed some code that actually takes the Ceres data and puts it into EarthRanger for us. So I just want to highlight here that even if the integrations aren't set up already on the ground, it's still possible to crowbar what you want into this if it's not a readily available feature, because we really want to have all our data in EarthRanger so that it's much easier for all our other outputs. And then we end up with, I don't know how familiar everyone is with the admin side of EarthRanger, but then we get this beautiful list of all our sources, which are all our tags, no matter what source provider they are, they're all there together. And then we create these source subject assignments where we can have multiple tags on one animal and we can keep track of everything there. Really, really nice way to bring everything together into EarthRanger. Just touching a little bit on how we integrate Ceres. We have code on a cloud-based computer, which is constantly searching essentially for Ceres data that comes in. And it picks it up and it says, I've found a point for this device, and it says, okay, sending it to EarthRanger. It sounds simple. We can ask Jeff maybe to say it's not simple. Jeff from African Parks helped me a lot with developing this code. But essentially, it's all doing it in the background, running on its own. The live feed is still there, and we don't have to worry about anything. EarthRanger doesn't currently integrate with MoveBank, but we have been a bit of a guinea pig at the moment at GCF, and we've been working on getting EarthRanger data into MoveBank via Gundi. So we'll all learn a little bit more about Gundi tomorrow, I believe. But for those who are not aware, MoveBank is a platform that stores spatial data, but also anyone can make a profile and log in and see all of the studies that are available to them. So this, for example, is all the studies that where I'm the data manager, and you can see down the left all the countries and sites, and then they can take a look and see, okay, they had 32 animals tagged in northwest Namibia. I would like to have that data, submit a data request, and then we can share data that way. It's a really nice way to increase collaboration, people to be aware of what studies you have because they can't see your EarthRanger instance, so everyone knows what's available. And some source providers do feed directly into MoveBank, like Savannah Tracking, for example, but lots don't, like Ceres and GSAT. So again, we really want to have that complete package where everything's everywhere and not bits and pieces, and we can't keep track of anything that's available there. Everything else we collect is done by us via Survey 123, which is an Esri ArcGIS Online app. Translocations, the drugs that we use, the dosage, how many animals went from point A to point B, how many snares were removed, how many kids were taken out into the field, general population monitoring, marking when you've seen an individual. All of that we do in Survey 123. And then that feeds into our ArcGIS dashboards. So here is an example of one of them from the Northwest Namibia Monitoring Project. So every month, one of our team members goes out into the field, drives around, tries to find all the giraffe that he can, takes pictures of them, writes down who it is, into Survey 123. He's out of signal, works completely offline, and then he gets home and he presses sync, and then this dashboard updates for him. So in the top corner, we can look by survey, single survey, or look for the whole year, or look for the past 10 years. And it automatically then updates the population size over that time period. Sorry, I'm probably too short. The population size over the period, all the sightings that he had, the percentage of the population that he saw at that time. Over on the left there, it's how many new babies there were, the sex breakdown, number of herds, everything that he needs for reporting, basically. So it's drastically reduced the amount of human hours that are required once he gets back from the field. So he presses sync, this automatically updates, and then that's his reporting. It's made a huge difference to workflows, and also making sure that there's data integrity, stuff doesn't get lost, pieces of paper, Excel files galore, it's all stored there in one place. Another example of one of our other projects, this is the environmental education program, and their dashboard shows how many workbooks have been given out over a period of time. That's accessed in the filters in the top there. How many kids, 1,777 kids this year have taken out into the field. They've done 94 days out. And this is actually also used in keeping track of orders. How do we need to buy some more books? How many books have we given out? This is also really nice for donor reporting. If you haven't set the survey up perfectly, which happens a lot, it is also possible to use the arcade data expressions in ArcGIS Online and sort of force it into what you need to show in the dashboard. It can be a little bit clunky, but in this example, it's bringing information from 2 different surveys into the same dashboard. So that's also a possible thing to do. EarthRanger also links with ArcGIS Online. So this is a feature layer inside ArcGIS Online that is receiving data every day, refreshes at like midnight, from EarthRanger, and it summarizes all our sources, and that's all the tracking units on the giraffe. So it tells us the last location, how many points over the last 7 days, if it's currently deployed, etc. And while this is really great information, it can come directly from EarthRanger. EarthRanger only tells you information about the tracking units that are turned on or that have been turned on. Maybe they went offline, but they need to have been switched on at some point for you to be able to get information about them. And I take information that I log about all our orders, everything that's offline in Survey 123, and I join those 2 things together to give me this sort of day-to-day operations dashboard. So I can see the stock of what we've got at the office. So when someone calls me and says, I need to send 10 units to Kenya, which ones can I take? But there's also, we need 5 for Rwanda, and this one's turned on, but that one's not. It's joined together. So again, bringing everything into one place so we have this big overview. So this summary also says how many units we've purchased, 1,080. 200 are currently functional. On the right, you can select a unit ID, and it tells you its performance over the last week, its little GPS location on the map, and its life history, basically, because all sorts happens. I'm sitting in Johannesburg, and someone's taken 10 from Namibia to Rwanda, and everyone in the team probably hates me because I'm like, what date did you take them? Why did you take them here? Did you turn it on? Because all of this is really important, but it's very easy to get lost. So bringing all this together with the data we get from EarthRanger, I use this for my day-to-day operations, and it saves me a lot of time in keeping track of what we've got available, what we need to buy, and just generally increases our efficiency, allowing us to spend more time on activities that are actually making an impact. Ultimately, what I'm getting at is what can look like a complex workflow with lots of activities and lots of different data sources can all combine into single, or in our case, double data platforms in order to make things more efficient. So for us at GCF, that is EarthRanger and ArcGIS Online. There are 2 twin data hubs, and I'm very excited to find out more across the next few days about how I can maybe make more of these lines dashed lines so that I have even more integration and make things even more efficient. Because essentially, we want all of these outputs quickly and efficiently so that we can achieve our goals. That's the whole point. We don't want to spend time repeatedly running code to find this answer to this question when it should be all automated, just to make everyone's lives easier. Because at GCF, we're very proud that we use science to act decisively and address giraffe conservation needs. So not only do all of that information from the dashboards feed into impact reports, this is a screenshot from our latest annual report, a little infographic about the impact that we've had. We also feed a lot of our data into scientific publications as well, and we work quite hard there with lots of partners and collaborators. So I mentioned at the beginning about the tracking units. We've tried all sorts, we, GCF, and lots of other people. So we have a paper in review at the moment describing this evolution of tracking technology. I went through every paper that I could find that said anything about collaring a giraffe in some way, shape, or form, and tried to get as much information as I could, and then I joined it with data from 487 GCF deployed units across all 4 species of giraffe, 15 countries, over 2 million data points, to try and understand what's working, what's best to use. Is there maybe a certain area that might work better for this type versus this type? And a lot has happened over time. This little timeline just shows from the first neck collar on the left in, I think it was 1970, was like 10 kilograms, to these ear tags that weigh just a few grams today. There's been a lot of in between, and I'll go through some of the main ones with you now. I have already mentioned the neck collars. The first ones that did try the tight one at the top didn't really work out. And then we tried these larger ones that go over the shoulders. This was in the 90s, so it wasn't like perfect GPS. It was still lots of cabling in there and everything. They twisted around, broke the cables. Some of them fell off. Didn't work very well. Even when, like on this one, for example, we attached like a little bra harness. Also didn't work out so well. So, okay, neck collars can't work for giraffe. What can we do instead? That's when the little head harnesses or these little rugby scrum caps came in. And although they gave good data, they don't fit very well. And it's not one size fits all. Ossicones are different shapes and sizes. Skulls are different sizes. Sometimes you have to put them on back to front just to make sure it stayed on. So it's not really a viable solution or something you can roll out across all giraffe. We tried little ankle bracelets, Fitbits. They didn't work out so well. Too low to the ground, too much interference. And then eventually settled upon this we call the Ossi unit that was mounted on the ossicones. Has a little solar panel, and these are iridium units. They give hourly data, or actually up to 15 minutes. And they worked really well. They worked really well, but they're quite hard to put on. Requires a lot of time when you're in the field and the giraffe is down and everyone's stressed out. Trying to get it on can be a bit complicated. So that unit was taken and modified a little bit, and now we put it on the tail. So it straps just around the tail above where the hair starts, that stops it from falling off completely. And these ones have been really successful, and that's now the main tag location that we use for giraffe. In addition to ear tags, that one on the left, that's a Ceres ear tag, and this one on the right is a GSAT solar tag. They weigh about the same, they're about the same size. And we're still testing and trialing those in lots of different places to see how that can work as well, because it also depends what you need out of it. These ones are global star network, so you're not going to get hourly perfect data like with Iridium, but they can still be very valuable for answering a lot of questions. So essentially, all of this information, along with the performance metric of every single unit that GCF has ever put on a giraffe, is going to be published in this paper. So we really hope that by being open, that this can then improve and other people can use it, and we can all gain by sharing this kind of information. Other work that we do, I mentioned that we conduct photographic censuses. In 2019, our colleague Michael Brown, he looked at the distribution of giraffe in all of Uganda. So he used all historical data that he could find, along with 3 years of GCF surveys. And he found that back in the day, this is 1960, These colored blocks represent the population size in each of the different parks. And today, 2020 rather, 90% of Uganda's giraffe population were in Murchison Falls National Park on the northern bank. So from this, we can see that's risky. No one wants their entire country's population to be based on one park. What if something catastrophic were to happen? So now from GCS perspective, we know that all eggs in one basket is not a great strategy. So we can push to reinforce other populations, and this just shows how understanding historical distribution and changes can be used to inform future conservation decisions. We have a PhD student at the moment, Ellie Harris, who's based at the University of East Anglia, and she is looking at changing climate envelopes. So essentially, where's going to be okay in the future? Using all the climate data and model projections along with all the data from our GPS units for giraffe presence and all the other open source information that we could get our hands on, really. She has made some models to show where's going to be good for the different giraffe species in the future. So this figure, for example, the red range here shows the suitable climate for Angolan giraffe now. That's where it's okay for them now. This like yellowy white area, that's where it's going to be still okay for them at 2 degrees warming. And these blue patches, these 2 tiny blue patches, that's where it's going to be still okay for Angolan giraffe climate-wise at a 3.2 degrees warming interval. So from this, we can prioritize. Be like, okay, we know we're going to have to put effort into making sure that the giraffe populations in these blue areas are remaining stable and are doing well, because that's going to be really core important areas for them in the future. Something a little bit more localized, we had an MSc student, Rachel, and she looked at seasonal changes in habitat use of Kordofan giraffe in and around Zakuma National Park in Chad. So using hourly GPS data from 17 units over 3 years, she showed that the giraffe are actually moving out of the park seasonally. So this black line is the park boundary. Oh, sorry, it goes up there. And in the wet season, they're moving out due to seasonal flooding. But to protect this largest population of Kordofan giraffe, we now know that we need to make sure that these areas aren't then transformed for agriculture or anything like that in the future, because then we know that the giraffe need to leave the park in the wet season. So this sort of scientific analysis really feeds back into our priorities and how we need to make sure we're protecting giraffe. We had a postdoc fellow, Ramiro. He created open source workflows for species distribution models. This integrated with Google Earth Engine, so all the open source satellite data, and he used data from 31 units that were put onto reticulated giraffe in Kenya. And from here, you can see he predicted where's good habitat, the yellow bits, and from there we know where might be priority areas or areas for corridors. But also, what's really important here is that there's an open source workflow, so anybody can use it. You can plug in data from any species and harness the power of all of that open source data that's on Google Earth Engine. And lastly, Michael, a colleague at GCF, he also took, for a couple of years ago, he collated everything we had GPS-wise, which ended up being 200 units across the 4 species, 10 countries, and 30 distinct populations to look into, in general, in Africa, how does anthropogenic disturbance impact movement? And from there, he was able to show that Home ranges and movement rates were low in areas of high human impact. So basically, humans are barriers. But we also know that home ranges in areas where resources are sparse, the giraffe move a lot. So this has impact for areas where resources are dispersed, but there are a lot of people. How are the giraffe going to be able to move around in order to get what they need? So that has important implications there. I've talked mainly about the scientific outputs we have from our GPS units, but the vet team also has published things on disease and chemical immobilization, but I could talk for a long time on all of that. So I'd like to sort of open the floor to everybody to talk about moving forward and ideas that you might have for data integration, or if you want to know more about something that I've mentioned today. Because we really want to move forward and further collaborate with the wider EarthRanger database and community. For example, because EarthRanger makes such a nerdily beautiful, formatted, perfectly database, the code that I use to summarize that tracking information from all those different GPS units could be applied to anybody's data on EarthRanger. So we could essentially, as a larger community, band together and do that same analysis for all species, all units, all temperatures, all vegetation densities, and really look at what works and really try, bring everything together and be able to make better informed decisions, spend money better, it's better for the animals, win-win. Really excited about further data integrations with EarthRanger and Viagundi. We're currently trying to integrate our survey route tracking and our fence mapping in with everything else, trying to make it all neat and saved nicely in the same place. And for further developing AI for individual identifications and better platform integration. So I mentioned we use Giraffe Spotter. It's a little clunky and a little user unfriendly, doesn't integrate very nicely with other platforms, but maybe this is something that can develop and change with Gundi moving forward and all the new things that are on the horizon. So if anyone wants to talk more about that or share their experiences, that would be really, really great. Because at the end of the day, conservation is truly collaborative. GCF, we work with loads and loads of different partners. I mentioned special partnerships with AP and EarthRanger. The tech team have been really, really great in helping me with a lot of these integrations. Everyone's always really supportive. We want to keep that going because GCF, we just want to be a voice for giraffe. So thank you very much. And I'm going to leave this up. If anyone wants to email me or WhatsApp me, or you can grab me later and we can talk more. I'm excited to see what everyone else is doing. Thank you. I mentioned some of our code workflows, that they're on GitHub as well, so sharing things code-based if anyone's that way inclined. You can also give me a shout. I use code to pull data from EarthRanger to do summary reports. What else? I use code in Python to pull my shapefiles out of ArcGIS Online into my workflows. What else? Yes?
I would love to hear more about that analysis of automated population size that you're doing. Can you repeat the question? Sorry, I thought I was shouty enough. But I would love to hear more about the population analysis that you're doing kind of automatically and how exactly you're doing that. Is it like based on the photo identification of the giraffes and what would the statistics be? I would love to hear you talk more about that.
So the method that we use is called, it's really mouthy, spatially explicit capture recapture, SECR. And essentially, it works out, some clever statisticians worked out how to make this package work. You do a route several times. I'm going to do a practical example. Let's do a route around the park 3 times. Take a picture of every giraffe that you see. find out which ones are the same individual, and from there, this statistical workflow can interpret based on how many giraffe you've seen, how many you've seen more than once. This is probably the population size of the entire area based on the kilometer squared area that you covered by the road and with your vision of sight. Does that make sense?
Yeah, so we do something very similar for North Atlantic right whales. We use a similar model for North Atlantic right whale habitat modeling, but we update our model once a year. So I'm really interested in how you're doing it faster. So maybe we can chat more about that.
Yeah, well, we also only do these surveys once a year. So someone goes out into the field for a few weeks, drives around and around, looks for lots of giraffe, comes home, and then sort of once the pictures are processed, we've pulled out the giraffe ones, throw them into Giraffe Spotter, get the IDs, then we can do the analysis. That's why it's a little bit clunky for me at the moment. I would like to speed that up. Yeah. Yeah.
Thank you. Thank you for the great presentation. My name is Michael Koske from Save the Elephant. I am more interested in the integration bit of between EarthRanger and ArcGIS Online. I think we have been doing it kind of manual, but I see that you have an automatic process of integrating the data. So is it wildlife tracking data only, or it includes even reports from EarthRanger? And what do you use to, is there a program I install in ArcGIS so that I can get the data directly from EarthRanger?
Yeah.
Thank you.
So EarthRanger can send all its data to ArcGIS Online. And I did set that up for all the tracking data, but then I got a really big bill because I was using too much space because we have too many tracking points. So I actually don't have any of the tracking data go in there because it's too much. We only have a small amount of credits on Esri, so it's too much for us to have all the tracking data go in there. But that is possible. EarthRanger can push that directly. You don't have to do any second platform or anything like that. But to get around my storage limitations, sort of created a summary. So I've got more code on a cloud-based computer that says to EarthRanger, please tell me every day a summary of how many units are out, what was the last location, how many points, like summarize it into a small file, then send that over to ArcGIS Online. And it doesn't take up all my space. And then I use that to summarize for my dashboards. But it is possible, if you talk to the EarthRanger tech team, that they can push all the tracking data into ArcGIS if that's what you need. But watch your credits because it takes up a lot of space. Does that answer your question?
So I understand EarthRanger is moving towards Ecoscope for the reporting needs. What are the parallels between what you're doing and what is available on Ecoscope?
Seems like a lot. Yeah. Yeah, no, I haven't had chance to interact with Ecoscope, but it does sound like it's a lot of the same, essentially the same pathways that are working there. Exactly, yeah. So it should be a really nice way for people to summarize data into dashboards, but also it seems like for automated reports as well, if I'm not mistaken. I don't know very much about it, but essentially it is going to be the same kind of workflow as I just described there, where all your data can feed into one place. I believe it sort of sits on top of EarthRanger, if I'm not mistaken, and you can pull out all your summary information for whatever you need. Yeah. So maybe I did a demo for Ecoscope.
Two ways Ecoscope will help. One is, yeah, it will build out those dashboards, but actually if you've got analysis that you've created, you will be able to publish it into Ecoscope and make it available. So Ecoscope, it's not just a solution which is going to have a set of dashboards and that's it. If anyone is working with any set of data, or any set of analysis, they'll be able to make that analysis available to the community. So it'll enable,
Thank you.
yeah. And the other thing is, it will sit on top of EarthRanger, but also potentially on top of Smart, Google Earth Engine, a range of other tools as well. So it will also allow you to bring data in from a broad range of sources.
Thank you.